Okay, so this is a challenging question when we have an incline plan that is an object with a given mass is at an angle of the incline, let's say 28 degrees, and we are looking for the coefficient of the friction so that the object is stationary, meaning that is not moving. So you are placing the object there at the top of the incline, and the object is not able to move as a result of the friction that is between the surface of the incline and the object. Now, we start by drawing the free body diagram as the object of our interest represented by a dot, and then force of gravity that is going down toward the center of the Earth, 98.1, because 10 times 9.81 is 98.1. This is the surface, and force normal is this way. And just so that we are doing the horizontal and the vertical components of the forces, we are assigning the new horizontal and the vertical axis as the natural way that the direction of the motion that the object will move, and the angle between the extension of the vertical axis and the force of gravity will be the same as the angle of the incline. So then what we have here is the horizontal component of force of gravity, vertical component of force of gravity, and the horizontal component of force of gravity. So now if we construct the table of components with the new horizontal and vertical axis, then we will have force of gravity, force normal, force of friction, and then at the end is force net. So now horizontal component of force of friction or force of gravity is equal to 0. The vertical, no, not 0. The horizontal component of force of gravity is positive because it is on the same direction as the horizontal axis, new horizontal axis, and will be 98.1 times sine 28 degrees. And it is positive 46.1, let's say, if you round it. The vertical component is negative because it's on the opposite direction, so will be negative 86.6. The horizontal component of force normal is equal to 0. The vertical component is positive Fn. The horizontal component of force of friction is negative force of friction, and the vertical is 0. Since the object is stationary, then it's not moving, meaning that acceleration is equal to 0. Therefore, force net is equal to 0. From the new horizontal axis, what do we have is 46.1 minus force of friction is equal to 0. And from the new vertical axis, what we have is force normal is equal to 86.6 newtons. Now take this information and replace it at the first equation. So 46.1 minus nu times 86.6 equals to 0. From here, the coefficient of the friction will be 46.1 divided by 86.6, and it is 0.53. And there is no numbers on it. Questions? So again, what is the coefficient of the friction so that the object is stationary? If you have an object with mass m, given mass and an angle theta that the incline is creating. So no numbers there at all. And you will see now that if it is dependent on the mass or not. So what do we have is we draw the free body diagram as starting with universal force, mg, and then we have an incline that is creating an angle theta. Here we have perpendicular to the surface, we have force normal. Extension of this axis will create the same angle theta here. Since we are assuming the same, I'm repeating the same words, is the direction of the motion. Now, you may say that the object is stationary. Yeah, but if it was not, then the object will move naturally down the incline, creating a force of friction that is opposing the motion, is against the motion. So now we have the new horizontal axis and the vertical axis. And this is creating the vertical component of force of gravity and the horizontal component of force of gravity. Okay, now we build the table, horizontal, vertical. So then we have force of gravity, force normal, force of friction, and force net. So force of the horizontal component of force of gravity will be positive mg times sine theta, whatever is it. The vertical component will be negative mg cosine theta. Okay. Force normal in the horizontal is 0, in the vertical is Fn. Force of friction in the horizontal is equal to force of friction on the vertical is 0. Since it is stationary, both the horizontal and vertical are equal to 0. From the new horizontal, what we have is mg times sine theta minus force of friction is equal to 0. This is equation 1. From the vertical, what we have is force normal is equal to mg times cosine theta. Okay? And then let's replace this into the first equation. So we'll have mg sine theta minus mu times F normal equals to 0. Okay? Force normal, we just found that it is mg times cosine. So we'll have mg sine theta minus mu times mg cosine theta equals to 0. Or mg sine theta is equal to mu times mg cosine theta. So mass and acceleration due to gravity is cancelled because they are not 0, so we can simplify. And then from here we can find that mu is equal to sine theta over cosine theta, or equals to tangent theta. So as you see from here, tangent theta, let's write it nicer, is equal to tangent theta. So as you see here from this calculations or manipulations that we did, the coefficient of the friction that the that it should be between the object and the surface in order for the object to be stationary is not dependent on the mass at all. So now we again are keeping it as general. So we have a mass m and placed into incline, and we are looking for what is the coefficient of the friction so that the object is moving with a given acceleration a. We'll start again drawing the free body diagram. So this will be a force of gravity that is mass times acceleration due to gravity. You will have force normal perpendicular. We'll do the same thing as we did before. Those are the new axes. This is angle theta. And then the direction of the motion is this one here. And force of friction will be against the direction of the motion. This will be the vertical component of force of gravity. And this one here will be the horizontal component of force of gravity. So let's build the table. New horizontal, new vertical. Then we'll have force of gravity, force normal, force tension, force friction, and force net. So force of gravity in the horizontal will be mg sine theta positive, and in the vertical negative mg cosine theta, 0 f positive f normal, negative mu times f normal, I will just say it here, and 0, and on the horizontal, since we have an acceleration, will be mass times acceleration and 0. From the horizontal, what we have is mg sine theta minus mu times Fn is equal to mass times acceleration. And from the vertical, what do we have is force normal is equal to mg cosine theta. Let's substitute this in the relationship on 2 at the first equation. And then we will have mg sine theta minus mu times mg cosine theta is equal to mass times acceleration. Now mass is the only one that is common in all terms. Then we simplify mass, and this tells us that again the coefficient of the friction is not related to the mass. So then we will have g times sine theta minus a is equal to mu times g times cosine theta. And from here, we can say that mu is equal to g times sine theta minus a, the whole thing divided by g times cosine theta. So in a difference with what we found on the previous one, that mu was just tangent theta, this is a bit more complicated, but still not dependent on the mass of the object. So as you see here in the relationship, we don't have any mass as a variable. Is it